Hello, everyone. Welcome you to study MA4822, which is about the sensing and the measurement system. Today is the first lecture. Therefore, I will use this opportunity to give you a short introduction to this course. In this short introduction, I will cover the brief introduction about myself. Then I will give you the big background behind this course. So I will tell you something about the Internet of Things. This is one of the hot topics in today's industry and today's society. And inside the Internet of Things, there are two major devices. One refers to sensor and the other refers to actuator. Therefore, it is good for you to understand this big application context of this course. Then lastly, I will give you some guideline and instruction for you to study this course. So let me begin with a short introduction about myself. My name is Xie Min. I am the associate professor with NTU since 1999. And I received my first degree in control engineering from China. Then I received my master degree and PhD degree in France. Both my master degree and the PhD degree are in the area of informatics. In terms of my research achievement, I have published this monograph on robotics in year 2003, and I have published this monograph on artificial intelligence in year 2021. And in year 2008, we have undertaken this project on adult-sized humanoid robot in Singapore. In year 2004, we have launched this International Journal of Humanoid Robotics. In terms of my teaching portfolio, you could find the detail from my homepage, right? And this slide shows you my research spectrum. And you will see my research cover basic research, applied research, and product innovation. The two keywords underlying my basic research are intelligence and motion. And there are four pillars inside my basic research. They are cognitive vision, cognitive speech, intelligent design, and intelligent control. In terms of applied research, you will see my interests cover all these topics inside the middle rim, okay? And in terms of product innovation, my interests cover industrial robot, medical robot, special robot, and service robot, all right? And this slide shows you 4 videos from my research project. And you will see all these projects involve the use of a sensor or measurement system. For example, this video shows you autonomous hand-eye coordination undertaken by humanoid robot. This is the result that we have around the year 2008. The robot make use of object in front of it, then measure the location, the arms motion and the fingers motion, arm and the finger. Then you understand for the robot must make use of
I close my hand. My arms ready position. Yeah. I protect, I guess.
All right. Now, this video show you human-robot interaction at the signal level. Again, you will see this robot will make use of function from human operator. When you switch, the robot will be able to automatically adjust its position and the orientation of its body. All right. And this video show you another demonstration within the context of human-robot interaction at the signal level. So you will see now the robot make use of the vision system to detect the intention of a human operator, right? Then this video show you the scenario of human-robot interaction at the cognitive level.
I understand that you say prepare walking.
Yes.
Okay, I'm doing it.
So you see, this is a dialogue with the use of human language.
I understand that you say walk forward.
Yes.
Okay, I'm doing it. I understand that you say look backwards.
Yes.
Okay, I'm doing it.
Right.
I understand that you say turn right.
Yes.
Okay, I'm doing it.
Stand up. Stand up.
I understand that you say stand up.
Yes.
Okay, I'm doing it.
Detect object.
I understand that you say detect object.
Yes.
What color is the object?
Red.
Detect read object.
Yes.
I can approach the object by following steps of 1.45 meters.
You see these 4 videos which highlight to you about what we have done more than 10 years ago in NTU, right? And this picture was taken by journalists, and this picture has been publicized in the news media, right? Okay, now we move on to introduce the background, okay, about this course, and I use Internet of Things to introduce you to study this course, because Internet of Things include Internet of Sensor. All right, so I will guide you to go through the basic detail behind Internet of Things. All right, So the first question you may have in mind is about the what are networked system, because the Internet of Things belong to networked system. All right. Then before you will be able to understand what are the network systems, so let me give you a definition about the what is a system. All right, so a system is a set of interrelated elements which add together for a common goal. So this is a definition of a system. For example, here you see a car system, and inside the car you may have many other subsystems such as engines subsystem or air conditioning subsystem, lighting subsystem, braking subsystem, etc., or suspension subsystem, etc. Right? And then what is a networked system? Okay, so networked system is a system which is built on top of a feedback control loop with three basic units such as a sensor, controller, and the actuator. Right? So from here you see the appearance of a sensor. Okay, so sensor is one of the building blocks inside feedback control loop. And here you see humanoid robot. Okay, the humanoid robot has a biped walking system, manipulation system, grasping system, vision system, speech system, power system, etc. All right. Then inside every control loop or feedback control loop, there must be a presence of a sensor. So therefore, you understand the importance of a sensor. All right. Then in the society or in the industry, what are the typical networking system? Okay, so actually today you can find many networking systems in many places, such as in factory, in home, hospital, school, and the city, etc. All right. And here is a video we show you the subsystem inside the humanoid robot, such as manipulation system, grasping system, perception system. All right. In order for this robot to perform this type of action, you can imagine, okay, there must be a presence of a sensor inside the system. And this slide basically shows you a typical example of a network system. At the lowest level, you see we have a device such as a sensor and the actuator. So these are the two categories of a device inside the Internet of Things. When we talk about the Internet of Things, this things basically refer to sensor and the actuator. Okay, so these are the two major category of a device. All right. Then on top we may have a controller, a networked controller, networked workstation, etc. All right. So this is a typical example which showing you the detail. Okay, about networked things. All right. And then we can deploy such networked system in factory, in school, in hospital, etc. All right, or even inside a robot, we can consider inside a humanoid robot itself, we have a network. Then we have Internet of Things or mini version of Internet of sensor, Internet of actuator. All right, okay. For example, in the factory, we have a production line. Then here you see a lot of robotic arm. We can consider robotic arm as a mega actuator. And inside the robotic arm, there are many sensors: position sensor, velocity sensor, force torque sensor, etc. All right. Then we also have testing equipment. You see machine vision is there, and controller, right? So machine vision basically is a visual signal sensor channel inside, all right? And then machine automation, you see industrial robot, autonomous automated guided vehicle. This is AGV. So inside AGV, you also have a lot of sensor there. Then for all the industrial machinery, there must be the presence of a lot of sensor. All right. So this gives you an idea about the network, the sensor, network, the actuator. All right. So you just consider from these two angles, then it's easier to understand the scope of Industrial 4.0. All right. Then here you see the MES is a manufacturing execution system. This is like a operating system of a factory, operating system of a production line. So you understand for every computer, there is an operating system. Then in future, for every robot, there must be operating system. Every car, there must be operating system. Every factory, there must be an operating system. Every city, there must be an operating system. All right. And in the home environment, in future is the same. Every home must also have an operating system. Okay, because the home has many specialized space, such as a bathroom, bedroom, living room, office, garage, kitchen, and bedroom again. So inside every space of the home, we may have a sensor, we may have an actuator. Okay, we can consider, let's say, vacuum cleaner is a mega actuator, and the inside vacuum cleaner itself, they must be sensor. All right. Then for refrigerator, TV, and oven. Okay, or inside the garage we have a vehicle, and we also have a power supply system, water supply system, and the air conditioning system inside the home. Then immediately you understand a home is also a kind of Internet of Things. These things may refer to sensor and actuator. All right, so this is for you to understand, okay, the importance of application with the use of sensing and the measurement system. All right, so in this way, you will feel excited about the study of this course. All right. Then in hospital, is the same. We may have a different type of a hospital, regional hospital, local hospital, flagship hospital, and we have a lot of data being collected from the patient. Okay, you may heard of this technical term, big data. So immediately understand, without the network, the sensor, how can you collect big data? So big data must come from network, the sensor, or network, the sensing and the measurement system. All right, automatically you understand the importance of sensor and the measurement system. All right, and then we have operation room, operation theater. So all these are operation room, operation theater. So you see we have a lot of instruments. All these instruments could be considered as a sensor, actuator, plus additional one we call it a display. Okay, so these are the three major devices. All right, but without the sensor, then you have nothing to display, John. Okay, so sensor, actuator, display device, all these are the major, okay, component inside Internet of Things, right? Then for school, you know, okay, in the university, we have many classrooms. Inside the classroom, we also have a sensor which detects the smoke, detects the light, or detects the vibration, detects the motion. When someone moves inside the room, the light will automatically switch on. So we have a motion sensor, smoke detection sensor, and light detection sensor, something like that. All right. And inside the classroom, we also have a display device, John. We can network all these things together, then form an Internet of Things. So then you can imagine inside the campus, we have Internet of Things, and the things refer to sensor, actuator, and display device. And the actuator refer also to the lock of the door. When the door of a classroom is being automatically locked. So actually this action is taken by actuator, okay? To lock the door, it's a kind of actuator, all right? And lock the window. So you see the presence of a sensor actuator displays device within the campus, all right? Okay, and in school, all right? Then in the city, then obviously you see we have a lot of factory, okay, which offer job to resident. We must have a shop which offer to the resident as well, because we want to buy food, we want to buy clothes, or we want to buy other appliances, okay, in order to support our daily living, etc. So therefore, a city must offer the job, must offer the place for people to buy food and other necessary items, all right? And also a city must offer school, must offer hospital, and also offer the house for people to live in, all right? So you see, a city is a networked system, and which include the transportation system, power supply system, water supply system, etc. All right, and the office building for administrator to work inside, etc. All right. Then now you may want to know what is IoT, what is Internet of Things, because in our society, in industry, in our home, in school, we see the presence of so many network systems. And what is IoT? All right. So this video will help you to understand the answer to IoT.
The Internet of Things is changing much about the world we live in. From the way we drive to how we make purchases, sophisticated sensors and chips are embedded in physical things that surround us, each transmitting valuable data. Data that lets us better understand how these things work and work together. Quantities of data, and how do we put that information to work? Whether we're improving the production of a factory or monitoring our personal health, it's the common and provides the common language to the devices and apps to communicate with each other. The Internet of Things platform. This platform integrates the data from many devices and applies analytics to shared needs. Let's start with a simple example, a car. After taking a long road trip, Rebecca noticed looked at by a mechanic, but is not sure whether it's something minor or something that needs immediate attention. As it turns out, the sensor that triggered Rebecca's check engine many monitoring processes throughout the car, which are constantly communicating with each other. A component in the car called the diagnostic bus gathers the data from all these sensors, then passes it to a gateway in the car. Only the most relevant diagnostic information will be transmitted to the manufacturer's platform. This gateway and platform must first register with each other and confirm secure communication. The platform is constantly gathering and storing thousands of bits of information from Rebecca's car and secure a database. The manufacturer has a signal that her brake fluid has dropped below a recommended level. The platform triggers an alert in her car. The manufacturer also uses the In this case, the manufacturer can deploy an application on the platform called the Asset Management System. This sells parts in their warehouses. It uses the data from directions to the nearest certified dealer, ensure that Rebecca's brakes are covered under the dealership so it is ready. They have also deployed hundreds of processes of the car itself. Other cars, the manufacturer pinpoint the exact the same part. All these pieces add up to streamlined inventory management for the dealer, a better, safer car from the manufacturer, and for Rebecca, Italy. All thanks to the Internet of Things.
Right, so this video roughly show you okay, the content of IoT. So IoT basically refer to network the sensor, network the controller, network the actuator, and also it may include network the display, etc. All right, so IoT is a distributed system. All right, and inside we have sensor, controller, actuator, display device, etc. And actually, controller basically serve as an interface to actuator, interface to sensor, interface to display device. So you can consider controller as a basic node inside IoT, because through the controller we can link, connect many other devices. Okay, into the Internet of Things. All right. So, and then what is a controller? Then immediately you understand. Okay. In order to study well this course, the prerequisite should be the study or the knowledge about the microcontroller. We have offer microcontroller course, okay, under the call of MA4832. So for those of you, if you have a study this course MA4832, then you understand that, okay, the usefulness, okay, with the use of microcontroller in order to set up Internet of Things, because through the microcontroller we can link or connect sensor, actuator, display device into the Internet of Things. All right. Then what is microcontroller? Basically, microcontroller has three basic building unit. One is the central unit of the microcontroller. I use this term, machine brain. So actually, this is the central unit of the microcontroller. So in which we can undergo, okay, data acquisition, data processing, and data storage, etc. All right. The other two basic unit are the input interface and the output interface. All right. So input interface is for us to interface the microcontroller to sensor, because sensor will output the data, then the data could be read in by microcontroller. The third unit should be the output device. Then we can output control signal to actuator or output information to display device. So now you see, okay, so with microcontroller, actually we can build up a network, okay, because input could also the information coming from other microcontroller. So besides the sensor can output information to the microcontroller through the input interface, all right? And the input interface can also take the information from other microcontroller within the same Internet of Things, all right? Then output here, not only output to actuator, output to display, but output to another microcontroller within the same network. Then you can imagine with this basic unit of microcontroller, actually you can, okay, build up Internet of Things. All right. Then how come a microcontroller has such a capability? The answer is because the blueprint, okay, of a microcontroller. So inside the blueprint, then you will see there is a support for arithmetic and the logic operation. So this is why microcontroller can do decision making, can do preliminary data processing, etc. And the microcontroller also has an input unit and the output unit. And besides that, microcontroller has a memory buffer to store knowledge, store information, and store program inside there. All right. So you see, this is a very powerful device. Okay. For us to use for the construction of IoT or Internet of Things, all right? And the typical example for us to use as a microcontroller should be the ARM Cortex-M series of a microcontroller. We may have a M4, M5, M7, etc. because this number we are going up, okay? But however, the working principle is the same, okay? So this is a family series. Okay, inside the family series, we may have a new member with more computational power, etc. But however, the operational principle are exactly the same. All right. So M stands for microcontroller. All right. So this is the M series of microcontroller. So this is a very popular one, and this type of a microcontroller is also very, very powerful and offer you the best, okay, performance price ratio, because it's not very expensive. Okay, so you have a very, very good performance price ratio. All right, okay. And in the market, you can also purchase development tool, okay, for you to build up the prototype of IoT. And here is just one example from Renisa, okay? And you can visit this web link in order to know more detail about this integrated development environment for IoT application. All right, so you see you can plug in many different type of a sensor to this microcontroller. So these servers are not inside the IoT, then you can attach sensor to it and eventually output instruction to display device or to actuator. All right. So that's about the IoT. Then next question you may have in mind is what are the possible application of IoT? So in the previous slide, I will already show you some example. But this example is for you to understand the presence of a network in the system. All right. So actually, we can link all this together to have a formal version of IoT. Okay. And then now I'm going to show you some video which highlight to you the important or impressive application with the use of IoT. Okay. So IoT could be deployed in order to support our everyday life, to support healthcare, to support smart city, and also to support disaster management in the city. And obviously, IoT could help us to make our industry smarter and more autonomous and etc. And also you see, we can also find the application of IoT in agriculture area. All right. So these are the major domain in which we could deploy IoT product or IoT system. All right. Okay. Then for our everyday life, we understand maybe you see this wearable technology. So in future, we can make our clothes, to serve as important node of IoT. Then we may have internet of people because through the clothes, because all the clothes could be interconnect within the community, for example, inside NTU campus. Okay, if we wear a special uniform offered by the university, and inside the uniform we have a wireless communication device, we have a controller, we have a sensor, we have eventually actuator to provide the mini cooling inside our body, for example. All right. So then all the faculty member and the student within the same campus are all interconnected together. Okay. Then if I have a request, I want to make a call to one particular student, or eventually I want to purchase something or order food or whatever, order drink, etc. So I can through the my clothes and through the use of let's say the handphone, I can issue the commands and send the request, and get the reply through the Internet of Things. All right. So you see, through the wearable technology, then the resident within the city can order foods from shops, can do online shopping, and also can control the lighting in the home, and eventually, and also can switch on, switch off the music, etc. All right. So, and can also book a transportation vehicle, right? And also know the schedule of the buses, and for long distance travel, and eventually the resident should be able to make a reservation of a flight, etc. Right? So these are the typical scenarios for the network or IoT to support our daily activity. All right. Then in the restaurant, eventually we can deploy IoT. Then in this way, the owner of the restaurant could serve the customer more efficiently, because the customer come in, come out. So that form a dynamic network. All right. Then through the use of IoT, maybe the quality of the service could be improved. and the waiting time could be shortened, and even how to set the bill, then the time of doing the payment could also be shortened. No need to wait for a long queue in order to order the food, in order to pay the bill, etc. All right, so these are the benefit with the deployment of IoT in restaurant. All right, and eventually we can make the kitchen inside the restaurant to be fully automated, and then eventually
Spice Robotics
robotize the restaurant.
is the brainchild of 4 MIT grads who think that by replacing line cooks with robotic chefs, they can make.
Started Spice wonder because we felt as though we couldn't get a wholesome, really great meal at an affordable price point. All our bowls are $7.50 using the technology. And as soon as you walk through the door, you get your first where you enter your meal from when you place.
Recipes are developed by human chef Sam Benson.
So here we are at the ordering station. We have 4 sections, all of them vegetarian, vegan, gluten-free.
Well, I eat everything.
Excellent, so do I.
How is it different?
When I had to make the menu, we made it very broad for customization and for a lot of technique to everything, which is roughly sauteing.
I'm gonna try that out.
I always suggest customers put your own twist on it without messing it up.
So what's something that you wouldn't let me add to this bowl?
Something that goes on our tikka masala bowl. Just wouldn't.
This looks really good.
Absolutely. You have a choice of your grains.
This is our order. Bowls and sauce. To get started, a robotic runner stops at the wok that will cook your meal and cut measure behind the scenes. Even though your food gets hot, the heaters stay cool to the touch. From there, a cook grabs it to put on the finishing touches. While that's happening, the wok tilts during the next meal. All allergens are kept outside of the woks, so there's no need to try. Chef Sam told me earlier that before they're served, all the bowl was sprayed with a mixture of lemon juice, bright, fresh, and acidity that kind of just makes you want to eat more.
We designed our systems to make them complementary to our work. The robot takes care of hard work. The hot, really, really great stuff people do, like customer service. Thank you very well. It's possible the industry will move in that direction, given the operating costs that restaurants do face. Restaurants are really only half about serving great food, and the other half is great, really critical. That's never going to go away.
So this is just like 15 cents. So even if you only ate out $12 a week, about $8 a month, join to your mother. Sunflower is complicated. So if I was making a guess at lunch, or that it's healthy and it's something like sweet green, just to save the
right. And then in hospital, then you will see there are many places like within the hospital itself for us to deploy IoT. For example, the doctor may want to know the real-time update about the critical data of patient under the care, all right? And the nurse may also want to have a real-time update about the instruction from a doctor, and also the critical data coming from patient under intensive care, etc. All right. So these are the typical scenario for the caregiver inside the hospital to receive real-time information about the hospital itself, about the operation room itself, about the patient themselves, etc. Right? And then these are the possible needs. You see, real-time data, and also make the device inside the hospital environment intelligent or smarter. Okay, for some simple issue, eventually the machine can make their own decision without waiting for instruction from a doctor or nurse, etc. All right, and also the IoT could help nurse or doctor to do a pre-processing of the data. Okay, instead of providing the raw data to doctor, to the nurse. Okay. The microcontroller can undertake data pre-processing, just highlight those important features to the doctor, to the nurse, etc. All right. So these are the typical needs, okay, from IoT in the hospital environment. All right. And this video will show you, okay, the environment in the hospital, and in particular in the operation room, operation theater. We have a lot of machine, therefore a lot of sensor, a lot of data. Okay, so it is good to interconnect all this data. Okay, all right.
I'm ready. We make no secret of the fact that we are determined to head right to the top. A beautiful example of it, I saw a machine that I'd seen 7 or 8 years ago in a lab building in Germany. And when somebody explained to me how it was going to be used, what more can you see of what we thought the future of the operation would be, and having an administration that was supportive of this future vision. We were able to, with a lot of people's operating rooms that have the state-of-the-art technology, but operating rooms of the future, where we're going to actually have 2 of these units in the operating room. Just the whole concept of what is changing. We're going to redefine what a surgical specialist is even, because it's an information technology expert. They have to be a radiologist, endoscopist. They have to be able to do minimally invasive surgery. They got to be able to do conventional surgery. This revolution is really this merging of intervention with imaging equipment and invasive surgery. In this room, at least 12 different image. With the electronic medical record, everyone has access to it. The surgeon has access to it. The anesthesiologist has access to it. The nursing team. We have the images from the endoscope, from the machines and the people that are taking care of the patient. Analyzing the patient's care, piece of information in the room. It's the nursing team, it's the anesthesiologist, it's the whole. There is that faces the patients. Everything goes around the country. And the acts of the patients' minds from different disciplines together about being an institution. Like donors like the Helmsley Foundation to environment. Basically, what this machine can do is, if you take fluoroscopy and spin it, you can see blood vessels in 3 dimensions. You can see solid tumors in 3 dimensions. You can see spinning motion. You can also create cross-sectional images. We're going to operate on the intestine. This machine will give you a simultaneous picture, and I'm going to be able to see outside at the same time. And this has the capability that we can overlay those images. So usually, where the patient doesn't is older, more accompanying diseases, and so minimize hospitals. That's what it's all about, right? We really want to push the envelope a little, be able to go with this, and I think that's really what we're going to be able to do. From what the standard find ourselves, and really, I think what it represents.
All right, so this is a typical example for the deployment of IoT in the hospital environment. All right, and obviously the largest area for us to deploy IoT should be industry, because there are many factories, there are many companies, many production line. All right, in which we could deploy IoT. All right. So in order to reduce the cost, to optimize the operation, shorten the cycle time of producing product, and also improve the quality of the product, improve the safety in the production line, etc. All right. So because production line or manufacturing system is a big system, okay? So inside the big system, we have many automation system, many control system. And inside each control system, there is a sensor, all right? So it is good for us to network all these systems together, then to form a very complicated IoT, and in order to make the future factory to be a manned factory or smarter factory, etc. All right, and then here you will see inside the production line we have many robots. As I mentioned, actually we can treat each robot as an actuator. Then we must link all these actuator together, okay, to form a network, form IoT. And each robot is also could be treated as a mega sensor, because inside the robotic arm itself, there are many sensors there. All right. So this is a hybrid. We can consider this robot as a hybrid device inside IoT, because a robot could play the role of doing actuation, and the robot could also play the role of doing sensing and measurement. Right, so this is a typical example for you to understand the importance of IoT, or Internet of the Things. And the things basically refer to sensor and actuator. But of course, you may also consider a display device, all right? But the sensor actuator should be the two major devices inside IoT, all right? And then this picture also show you, okay, the possible application scenario and the possible benefit for us to deploy IoT in the production line. Then this is outbound logistic. Eventually, we will have inbound logistic, etc. So you will see, okay, because manufacturing is a big system, and it's good to bring all these systems together. Okay, in order to have a network the sensor, network the actuator, network the display. Okay, something like that, right? And this video will basically give you a summary about what I've said to you just now.
There have been connectivity tree of the future look players. They know the key role in it will be more important than ever to operate quickly, becoming increasingly short. Just like lead time. Companies listen more rigorously to meet customer need, to digitize, automate, and above all only within the company, but also the convergence of part of the total process, anytime, real time, from product planning and logistics. Of course, data secure digital and physical values, so their efficiency, quality, and innovative capacity new, but to become affordable reality. As you can see, these challenges and questions, let's shape the future together. Secure KPI.
All right. And then besides industry, agriculture is another big domain of application for IoT, and agriculture is very important to the survival of city, survival of people or residents, because without the food, we cannot survive on Earth. All right. So the production of the food and the plant and etc. and the food, etc. are very, very important to us. Okay. Then in future, how to make farming smarter, more efficient, and increase the productivity from agriculture. So therefore, we can deploy Internet of sensor in order to monitor the condition of doing the vegetable planting, farming, etc. All right. So this is an area for us to deploy IoT in order to make future agriculture to be smarter. All right. And this slide also show you, okay, the importance to create a distributed control system. We collect the data from the field, then we make data analysis, and then eventually through the IoT to take action in the field remotely, because normally the dimension of agricultural field is much, much larger than the factory. Factory is relatively small compared to the large area for us to do the planting, to grow vegetable, to do the farming, etc. All right. So therefore, remote access, remote control is very important, right? Because due to the space constraint, right? So this is a typical example of deploying a distributed system, which include sensor and actuator, right? And even for vertical farming, so this is a typical example. In future, we may have built up like a farm, is a factory, or it's a farming house, all right, or building. So inside we can grow vegetable vertically, all right, instead of horizontally. Then in this case, we can save the space within limited spatial, okay, area. Then we just create space in the vertical direction. So we have a three-dimensional field instead of a two-dimensional field, because in the old day, all the field are two-dimensional. Okay, now we can create a three-dimensional field and the layer by layer. Then in this way, you will see again we need to deploy network the sensor, network the actuator, all right, in order to automate certain intervention during the farming process. All right. So this video will show you typical
The leafy
example.
greens are growing in. This is Jersey.
Our mission is to have access to fresh food.
Crops are foot space.
We're growing the roots. Our key vendor roots have a better
Allows them to use 95% less water than for herbicides instead of soil and instead of lighting.
A lot of people say plants don't need yellow spectrum, so we're able to reduce in certain types of spectrum.
Cycle in half so crops can be grown.
Water contamination comes from sewage, goes to agriculture, rated in the last 40 years. All these men a way to feed our planet.
Columbia University ecologist Dixon DePommier in nice farms could feed overpopulated. They would also cut greenhouse gases by eliminating the need to taking root. Over the including in Vancouver, Singapore, Panama, Farms is building out another new farm in a formerly operational. It's expected to produce 2
We listen to them, try and optimize on to stay.
farms will help solve our food products episode to see how
All right,
the leafy.
so you see, okay, for the deployment of IoT in agriculture domain, and in particular for the vertical farming, and in the video you see the control of the lighting. For the control of the lighting, obviously you need to have a visual signal sensor based on the sensory feedback. Then we can take action to adjust the spectrum of the light or frequency of the light, the wavelengths of the light, intensity of the light, etc., which are needed by a particular vegetable or plant, etc. All right, so this is a typical scenario for you to understand the importance of doing sensing. All right, then for disaster management in a city or in urban rural area, so immediately you see we need to have a smoke detector, fire detector. So okay, so fire detector, smoke detector could be based on the use of temperature sensor, because when there's a fire, then there's a radiation, then temperature may change at that location. We can also use a visual signal sensor, because when you see a fire, then the light ray will emit. So we can capture the light spot, okay, within a certain area. So this is just for you to think about the possible application, okay, from the sensor that you are going to learn or study from this course, right? And this slide also show you, okay, within the city area, we need to constantly have IoT. There's a citywide IoT. For example, in Singapore, eventually we may have a network of sensor just to monitor the smoke and the light, the fire, etc. Right? Or eventually collision or other type of accident or disaster. Right? So you can imagine the application with the deployment of Internet of sensor. Right? Then obviously in future city, we can consider a city to be a complex system, and everything inside the city are interconnected together. And therefore, you will see there will be a large amount of sensor to be deployed within a city, right? So you see the market for sensor will be huge, right? So I hope some of you eventually you could learn the knowledge from this course to venture into product innovation or venture into business world. All right, okay. Okay, this slide also show you okay the need from future city. For example, we may have education need, and for the street lighting control, we need to have a sensor, and smart parking. Again, we need a sensor to monitor the air pollution. We need to have a sensor. And for smart building, obviously inside we must have a lot of sensors: smart home, smart environment, and smart health, and the water supply, and traffic management. So you see, all these are the area for us to see the deployment of network sensor. Right, so I hope this background knowledge will motivate you really to study well this course. All right, and then this video show you some projection about the future city in year 2050.
70% of the world's population will be living in cities. Never have cities been so challenged, and the trend
safety few examples. Offer a multifaceted cities are hyper-connected cities. Their residents make access to electricity to analyze the use of energy distribution across the grid as related energy. A public platform where information on traffic or the city's pulse by exploiting entrepreneurs and means to build access. We want to businesses and society as a whole and thereby protect all actors.
All right. So that's about the impressive application with the deployment of IoT. Then you may want to know, okay, how to develop IoT, what should be the engineering foundation for you to work with IoT or develop IoT as a product, all right? So actually, I believe all of you already have the foundation. If you have studied MA4822, which is about the microcontroller, and then in this course, you are going to study all the major sensor, which could be deployed in industry, in the society, in agriculture, etc. All right. And for those of you, if you have also studied robotic course, I guess you should be ready, okay, to develop IoT as a product, okay, for industry, for society, etc. Right? So you will see the foundation, the first level of a foundation should be sensor actuator. So you see this course will help you to build up the knowledge and the skill with the design and the use of sensor, right? And then second level of foundation should be internet, and this basically is related to the knowledge about the microcontroller, because the microcontroller is a device which will support networking, okay, at the hardware level, okay. The physical support of networking based on the use of microcontroller, all right? So because in the course MA4822, which is about microcontroller, so if you have a study that course, then together with this course, I guess more or less you are ready already, okay? So edge IT basically is, it means distributed computing or distributed computation. And this is also covered already by microcontroller, because microcontroller can undertake some computation, arithmetic operation or logic operation, etc. All right. Then this cloud server data center, okay, this should be the infrastructure set up by the government normally or by big corporation, okay. So this is available already in the whole world, all right. So you just need to focus on level 1, level 2, level 3, and level 2, level 3 basically has already been covered by microcontroller. Okay, if you have a study MA4822 courses, I guess you should have already the engineering background, knowledge, and the skill. All right. Then from this course, you will enrich your engineering foundation about the sensor, right? And then what should be the engineering foundation? So this slide basically summarizes what I have said in the previous slide. So you will see at the lowest level, we have an IoT device. Among all the possible IoT device, the two major ones are sensor and the actuator, okay? Besides display device, etc. All right. Then on top should be microcontroller, which will provide the network interface, because microcontroller provide network interface to sensor, network interface to actuator, and the network interface to data communication. All right. So if you have knowledge about the microcontroller, then more or less you are ready to develop the IoT as a product. Then for edge IT or pre-processing or computation capability. So actually, today's microcontroller can also undertake certain type of computation or data analysis with sensory data. All right. Then at the higher level, of course, we have the data server, cloud computing infrastructure. All right. So this basically gives you an idea about the basic knowledge, basic skill that you need to have in order to design IoT as a future product. All right. Then in terms of sensor, now you understand, because our physical world is very, very complicated. We have so many physical quantity. Therefore, we have a lot of sensor. Each sensor will take care of one particular physical quantity. So this is the complexity about this course, because we face so many physical quantity. Therefore, we may have to study quite a number of sensor. All right, but for individual sensor, the complexity is not there. Okay, the complexity of this course is the wide spectrum of a sensor. For example, in this slide, we have ultrasonic sensor, optical sensor, and gas detection sensor, gyroscope sensor, and humidity sensor. All right, and photo detector. This is a photo detector, proximity sensor, etc. All right, and then this slide show you again as a family of a sensor that you may face, like acceleration sensor, vibration sensor, position sensor, acoustic sensor, flow rate, flow level sensor, humidity sensor, and position displacement, velocity sensor, temperature sensor, force torque sensor, and here it means the voltage sensor, current sensor, resistance sensor, capacitor sensor. Okay, in electric domain. All right. So you see, the complexity is due to the large family of sensor, but for individual sensor, the study is not so complicated. All right. So this is a nature, because this slide basically show you, highlight to you the nature of this course. Right. So obviously we must study quite a number of sensors within this course. But this is good news, because once you know working principle, design principle of all these sensors, then you will have more confidence about the design of IoT as a product in the future. Right. Okay. Then for actuator, actually, the size of a family of actuator should be much, much smaller than the size of a family of sensor. All right. So we basically have a motor, okay, the switch, okay, and I guess that's it. Okay, then you can eventually treat all the machine as a mega actuator. For example, robot, vehicle, airplane, or ships as a mega actuator. That's it. Okay, so the family of a sensor, or the family of actuator should be much smaller than the family of sensor. All right, and this slide basically highlight to you about my idea, okay, of considering all the machine as a mega actuator or mega sensor. Okay, then in this way, okay, so we can consider networking the robot as IoT, is a part of IoT, or networking the CNC machine as a part of IoT. That's it. Then our life is easier, right? So you see all these CNC machine, even 3D printer. If you put them together, you treat a 3D printer as a mega actuator. That's it. All right. So then everything is IoT in future in the whole world. All right. Okay, so then what will be the future challenge faced by our IoT? You may ask this question. Okay, is there any room for improvement or room for research or further development? Okay, etc. The answer is yes, because IoT is a very complex system. You have so many sensors, and to cover a large area, then the cost is an issue, and the cost is related to the power consumption. All right, and computational power, etc. So therefore, you will see energy is an issue, because we do not want to maintain IoT every quarter or every year. If let's say you can have an IoT which could last for 1 year without the maintenance, that will be good. All right. So then how to have the self supply of energy, or how to collect the energy from the environment without the top up energy manually by human operator. So this is the area of research to collect the energy from the environment. Or eventually, inside the IoT in future, we aim in the fourth category of a device. That is energy harvesting device. So we have a sensor, actuator, display device, and the energy harvesting device. All right. So then with these four basic member or basic IoT device, then we should be able to handle this issue. Then security is to prevent people to hack into the network, because once we deploy this network will be very, very powerful. In particular, if this network has actuator, so it means what? We can remotely to take action which will create a tremendous impact on the area, such as the city area or factory area or farm area, okay? And if someone with bad intention to hack into the network and take one action, then the damage will be huge, China. Okay, so security is become a very, very serious issue, because once you lost the control of access to the IoT, then people can create huge damage to a city, to a factory, to a farm, etc. Right? Then another issue is about the real-time update. Some sensor may be slow, and some sensor may have a huge amount of data. Then will take a long time to communicate over the internet. And the real-time requirement and the low-cost requirement, they are is in the contradiction. Okay, so because if we want to lower down the cost, then we must lower down the power consumption. Once we want to lower down the power consumption, then the computational power must be limited, and also the communication capability also must be limited. So therefore, so you see these are the two conflicting requirements, all right? So then how to balance these two conflicting requirements? So it's an issue, right? Then, okay, so then what should be the challenge by future automation in industry? Because for automation system, we can treat them as a mega sensor system or mega actuator system. So this video may also help you to understand certain issues based by IoT in the broad sense.
New technologies are changing, making the cars manufactured by the Volkswagen Group more efficient, safer, and the nature of car manufacturing. In fact, the next declaring the dawn of a new industry. So what is involving hundreds of identical vehicles lined up? The options available to customers are now objects. Data makes its way from the customer's order position of production. A car consists of many thousand processes, blanks for the bodywork. In the body shop, the car is baptized. In other words, it's given an RFID tag, which car body belongs to which customer order. The paint shop also receives information. In sequencing storage, the car. From here, information is transmitted to suppliers and pre-assembly. In final assembly, the finished car emerges. The Volkswagen Group manufactures its cars using state-of-the-art. What does the future hold in store? It is a term used to describe a variety of innovative production processes. But what exactly does it mean? The Volkswagen many years. Here are some recent examples. Digital essential for a new era in industrialization. Everything is given a virtual likeness in the system world. The result, for example, 3D printing. Pressing tools are no longer shaped in a 3D printer. It's a technology that opens the door on completely new possibilities for design, with a level of precision unknown into operation. In the past, protective grids separated robot arms and employees. In the future, employees and robots will work increasingly, and robots take on especially monotonous and arduous activities. Today, robots already factories and chemicals inside data. Example, big data monitoring logistics of data from the 1,200 suppliers of the Audi factory in Neckarsulm. Where are the potential bottlenecks? Where is the greatest need for actual times? The intelligent factor reduction unlike ever before. Employees, the Volkswagen Group has already begun actively preparing its workforce for the future. The world is changing, not only in the automotive industry. Everything is in motion, and the Volkswagen Group provides the
Right. So this give you idea about the future development and the challenge. Okay, faced by automation. So you will see energy security, real time. These are the three issues which may eventually present to the IoT deploy in the production line. All right, such as automobile industry. All right. Then in robotics, all right, so a robot itself you can treat as a mini version of IoT, because inside the humanoid robot, for example, we have an arm system, finger system, hand system, leg system, head system, body system. Okay, there are many actuators, many sensors. So this is a mini version of IoT, all right? Then what should be the challenge faced by such a humanoid robot? So again, energy is a concern, security, because we do not want someone else to hack into the IoT inside humanoid robot. Otherwise, such person or hacker could instruct the humanoid robot to do some damaging task. All right, okay, so then real time is another issue because when humanoid robot undergo motion or action in the real environment, so the real time performance is a critical issue. All right. Okay. Okay, so I hope that the previous slide will motivate you to study this course well, because sensors are the foundation of IoT, and the IoT will be the future in industry and in society. Then this should be good enough to motivate you to study this course. Okay, now I'm going to give you some guideline and instruction in order to help you to adjust your mind and during your study. Okay, first guideline is about learning or study methodology. For this course, we offer you recorded video lecture. So therefore, you are advised to do self-learning before coming to the live lecture, all right? But don't treat the self-study or self-learning with the video as the alternative to in-class learning or live lecture, all right? So this just for you to do a little bit preparation to test your mental capability in doing self-study, all right? So you spend 1 hour before the lecture. Then during the lecture, so that is a live lecture, okay? And because live lecture will use the updated teaching material, because it is not practical for us to update the video or recorded the video, because it's time consuming and manpower consuming to do the lecture video, okay? So we just provide the lecture video as it is, all right? Without the maintenance, without the update, all right? So such material should be good enough already for self-study, because we have, okay, live lecture. Okay, remember, recorded lecture video is not to replace live lecture. Recorded lecture video is to help you to do self-study or to do preparation before you enter the live lecture, all right? Okay, then we have a live lecture, so as usual, so we have scheduled lecture hour, etc. Okay, so you come and during the lecture, you feel free to invite me or ask all kinds of questions up to you, right? Then the third component is about the experiment-based live learning. So the good news is you have free access to MATLAB. Then you can use MATLAB to do a little bit of practice. Then another component is for you to undertake a project. So therefore, there's a project assignment. So project assignment, you consider it as a live learning because you must come out your own design, and you must document the detail about your design for your project. Okay, so this is a third component of learning. Okay, so I will give you the project assignment, so you consider it as a live learning. All right, so with these three components, I believe you should be able to enjoy your study about this course. Right, then you may want to know what should be the learning objective by this course. So the primary objective is for you to become a designer of a sensor. Sensor means a sensing and a measurement system, right? And the secondary objective is for you to become a user of a sensor developed by others, all right? So this should be the learning objective for you to remember, all right? So then as a student, you may always ask some common question. Question number one, you may have in mind should be why to study this course, all right? So the reason is because we are living, you see, inside the ocean of signal, and we are comfortable in navigating inside the ocean of signal. Then for future machine, if we want them to undertake autonomous perception, autonomous decision making, autonomous action taken, then we need to have an Internet of Things, okay, which could be deployed in industry, in agriculture, in society, in hospital, in school, etc. So therefore, okay, because the content of this course serve as a foundation of IoT, because without the sensor, there will be no IoT, because it does not make sense, okay, to have something that blindly take action without knowing the consequence, without knowing the outcome, okay, because sensor will provide the feedback about the consequence of your action, about the necessity for you to take action, channel, okay. You should never blindly take action, right? So without the sensor, there's no use to have for actuator, right? So it is giving you the strong motivation. Then how to study this course? This may be a common question that you may have in mind. So just now I already tell you the answer. Put yourself into the mindset of a designer. Then in this way, automatically you will ask this question: who are the user? What are the need of the user? So immediately you understand the answer to these two questions. Okay, so industry, agriculture, society are the user, because we want to have a networking sensor, etc. Right? So IoT will be the user of a sensor, because inside the IoT product, there must be presence of a sensor. Okay. Then what are the need of this user? Basically, is to obtain sensory data. So without the sensor, how to get the sensory data? All right. Then what should be the your Internet of a sensor which could meet the need of your user buyer? Okay. Then after the study of this course, then you should know, okay, you have a study this whole range of a sensor. Then what should be the possibility for you to come out the product which could be called as an Internet or network with a sensor or Internet of a sensor, all right? Then what are the solutions behind the design of your Internet of a sensor? Again, okay, after study of this course, then you know, because this course will help you to study all these solutions behind, okay, the major sensor in industry, in society, and in agriculture, all right? And in terms of the practice, here I advise you to make use of MATLAB, because you can have free access to MATLAB, right? Then third question you may have in mind is about what are you going to study in this course, all right? So in this course, I organize this sensor for you to study. So we have a sensor which cover electric domain. We have a sensor which cover mechanic system. We have a sensor which also could be deployed inside ecosystem. Okay, for example, temperature monitoring, humidity monitoring, dust monitoring. So these are the typical sensor which could be deployed in the ecosystem. All right. Then we have also sensor this course will also cover sensor, which will enable you to design intelligent machine, such as a machine guided by vision or machine which could undertake conversational dialogue with the use of voice or speeches, etc. Right? So this will be the coverage of sensor in this course. Right? Then the fourth question you may have in mind is how to apply learned knowledge in order to design sensor or design a network of a sensor. Okay, so at the lower level, so basically you just follow the guideline shown in this slide. So you may have two types of physical quantity for you to do the measurement. One refer to directly detectable quantity. Then in this case, you just need to have a front-end sensor. It should be good enough already in order to produce a computer readable or microcontroller readable value. For not directly detectable quantity, this is a common scheme. First, to convert not directly detectable quantity into directly detectable quantity. Then we use a back-end sensor to produce a computer readable value. Once you have a computer readable value, then always remember we need to do the calibration of a sensor. Calibration is to make sure the output from the sensor is exactly equal to the value of the input physical quantity. So another background knowledge for you to know is try to design your sensor as a static system. Okay, because for those of you with knowledge about control theory, we do not want the sensor to have a transient response. Okay, so we want the sensor to behave like a static system, and in particular, we want the transfer function of a sensor to be equal to 1. All right, so that means the output from the sensor is exactly equal to the input to the sensor. All right, so this is a guideline for you to apply, learn the knowledge, okay, to design your own sensor in the future. All right, then how's about the assessment for this course? So this course is very special. This course is a final exam free courses. So therefore you will not have any pressure about the exam, because I know some of you are afraid of an exam. Now you could totally free your mind because there's no final exam. So we spread out the quizzes over the entire semester. Then this way it will help you to manage your time, manage your effort to do the study with this course. All right, and this course also asks you to undertake a project. So you treat this as a third component in the study. So you remember we have video-based self-learning, classroom-based interactive learning, and also experiment-based live learning. So project is for you to do experiment-based live learning. And again, I'm not going to give you the pressure. Okay, you can come out the individual report based on the individual work, or you can group together, have a team with three students per team. You do the teamwork, but write your individual report. All right, so then in this way, you are not under pressure to do the study with this course, right? So that's all about the introduction to this course. All right, so the key takeaway from this introduction is for you to know a little bit about myself, and in particular is for you to know the impressive application in future with the use of network sensor in industry, in society, in hospital, school, office building, etc. All right, and also you know a little bit advice guideline for you to adjust your mindset in order to study well this course. All right. Thank you for your attention. I'm looking forward to seeing you in the study of the next lecture.